In this video, we're going to go through the 5.2.2 notes, which we did on Desmos instead of on paper. So there's going to be just a little bit you need to write down, but the most part you're going to follow along with me on your own Desmos. So be sure that you have this Desmos open, and we are going to go through the slides together. So this first one just asks us what the vertex is. So I want you to take a second and think about what the vertex is. You can pause it and then push play when you're ready. So remember, our vertex of these graphs are the very top or the very bottom of the graph. So for this one, our very top would be here at 1, 5. 1, 5. So our vertex is 1, 5. So then it says, hopefully you identified the vertex to be 1, 5. We did. That's great. Now I want you to pause this video and think about, what do you notice about this vertex related to the equation? How is the vertex related to the equation? So now that we're back, I noticed that the 1 from the vertex is in my equation. My equation says -1, but it at least has a 1. And then the 5 is also there. So the 1 is like inside parentheses and the 5 is outside of parentheses. That's what I noticed. You could have said other things. And now we're going to do it again. So for this graph, go ahead and pause this video and identify the vertex. So our vertex is -4, -8. And again, I noticed that there's a 4 inside here. This one's a positive inside parentheses, and mine was a negative for the vertex. And then on the outside is a -8, and that's what I have as well. So it looks like inside parentheses and the x value are related, and then outside of parentheses and the y value are related. So we are going to write this down in our notes. Oops. So vertex form is a way to represent quadratics that easily identifies the vertex. And vertex form has a very specific format or template. So we have an a value out front, that's just a number, a coefficient. And then we have x minus h inside parentheses squared plus k. So that is our vertex form. So now hk is the vertex. And h is a liar. So if we notice, like inside parentheses, h is negative, but our actual vertex is positive. So all that means is that when we are identifying the vertex, we have to actually flip the sign of our h value. So if our h is positive, we want to make it negative. If our h is negative, we want to make it positive. So pause this if you do not have these written down, and then let's actually start graphing. So now here is a quadratic graph, and a table really helps us organize our work. And so I've given you the table, but if I don't give it to you, we highly recommend like writing it down. And our first step, the first thing that we want to do is we want to identify the vertex, because we are not going to fill out this table using 0 in the middle. That would help us if all quadratics were centered at 0. But we don't know where our quadratic is centered. It's centered on the vertex, and we don't know where that is. So a good first step is to identify the vertex, and that will go in the middle. And so to find that, I'm going to look at my equation, and my vertex is h, k, and h is a liar. So inside parentheses is my h, and they are a liar. So over here, I'm going to start with 6. So my x value, my h value is 6 because it says -6, but it's a liar. And then my k value, the one on the outside of parentheses, tells the truth. So inside parentheses is a liar. That one comes first. Outside parentheses tells the truth. So I just have 6, 2 as my vertex. And now I want to come over here and choose my x values appropriately because I'm going to center my quadratic around this point we just found. So the x value for the point we just found, the x value for the vertex is 6. That's my middle. And now I need to have smaller numbers above and bigger numbers below. So I'm going to do 5 and then 4, and then down here 7 and 8. And so you see how we did not center at 0, we centered at our vertex. So that's a very important first step. If you always center your quadratics at 0, you probably are not going to get a very good picture of the graph. So now all we need to do is once we find these numbers, we're just going to plug them into this formula. So wherever I see an x, I'm going to plug in a 4. And the nice thing about this Desmos is that once you plug it in, so I'm just going to type it exactly as it's written, and you can pull this keyboard up if you'd like to type that way as well. So 0.5 parentheses 4 minus 6. And then down here on the keyboard, it's this a squared button plus 2. And once I click off of it, so I go over here, it'll actually calculate it for me. So you don't even have to use your calculator for this. This will calculate it for you. If you are using a calculator on a test or anything, you would just type this into your calculator and you'd get the same answer. So the point that I want to write down is this is my x value, which is 4, and this is my y value, which is 4. So 4, 4. And then we're just going to repeat this process. So instead of plugging in a 4, I'm going to plug in a 5. So 0.5, 5 minus 6 squared plus 2. Click off of it and it calculates it for me. So my x value is 5, comma, my y value is 2.5. Now I don't need to calculate anything here because I already have my answer. So I don't need to type anything in the middle. Down here, I'm going to plug in a 7. And I get 2.5. And so my point down here is 7, 2.5. Oops, 2.5. And you'll notice that like the y values match. So I have 2.5 here and 2.5 here. And you'll see a pattern as we finish out this last one. So my last one equals 4, so 8, 4. And you'll notice that the y value for the top and the bottom are 4. You should get this symmetry because our quadratics are symmetric. So you should get these two to match and the outsides to match. What I would not recommend is calculating the first one and saying, okay, this one's 4, so the bottom one has to be 4. Because if you made a mistake on the first one, and then you just copy it down here, now you've made 2 mistakes. So I'd recommend calculating all of them, and then if they don't match, make sure you didn't type anything wrong. And then if you definitely didn't type anything wrong, you probably got the wrong vertex. So you want to make sure you go back and check your vertex. And now these points are going to be how we draw our quadratic. So you can change the color of this pen, make it skinnier or fatter. I'm going to use an orange one because I think it shows up more. And I'm just going to plot these points. So 4, 4, 4, 4, 5, 2.5, so about halfway, 6, 2, 7, 2.5, and 8, 4. And so it should look like a U or an upside down U. If it doesn't, you did something wrong. So now I'm going to do my best to sketch this, but it is on the computer, so we'll see how good it goes. Not bad. And here's our sketch of our quadratic. So the really important part is making sure that this middle part is the vertex, using h comma k, which h is a liar. And then once you have your points, plotting them. Now you can try the next one on your own, but I do want to show you like some weird case scenarios. So in this first multiple choice one, it asks us which one represents it, and we notice there's like nothing inside parentheses. And so if there's nothing inside parentheses, that h value is 0. So our vertex would be 0, comma 2. Okay, so if there's nothing inside parentheses, it's a 0. And so just looking at these to find the vertex, 0, comma 2, this is the only one that has that as a value. So that is my answer. And it'll ask you to explain your thinking. Very similarly is this next one, but instead of not having a value inside parentheses, it doesn't have a value outside. So I want you to try that one on your own and then finish up this Desmos and submit. Thanks, everyone.